WINDExchange resource maps are a little different than your average reference or topographic map. In addition to displaying geographic boundaries and important topographic features, these maps display the quality of wind resources in a specified region. Built on the foundation of the Wind Integration National Database, or WIND Toolkit, developed by the U.S. Department of Energy's National Renewable Energy Laboratory, these maps can provide an at-a-glance reference of whether a region has quality wind resources at a given elevation. Wind speeds do not necessarily correspond with the topography of the map, and wind speed data may contain regional uncertainties. That's why it's important to note that these resource maps are intended to help educate you on what wind resources are like in different places around the country. More detailed local measurements should be taken before developing a wind project. At the end of this video, you should understand how to read the new WINDExchange maps, the difference between land-based and offshore wind resource maps, and where to access these new WINDExchange maps. Let's take a look at this wind resource map from the New England area. Like most maps, wind resource maps have a legend to orient you. Color values on these maps correspond with average wind speed. Multi-year average wind speed measured in meters per second is displayed on each map. On this map, the speeds range from 4.5 meters per second at the low end of the scale to 10 meters per second on the top end of the scale. This is a viable range for today's wind energy technology. It's important to read the map's legend because maps do not share the same wind speed scale. For instance, this offshore wind resource map of a similar region catalogs resources at the same height of 100 meters, but the scale ranges from 7 to 9.75 meters per second. While the wind resource scales may change on each resource map, the color scheme and shading will remain constant. Areas with higher than average wind speed are depicted with deeper blue shades, and areas lighter in color indicate lower average wind speeds. This is the map's scale bar. It can help you understand distance on the map. As was the case with average wind speed, the scale formed for distance on each map varies. In the case of this land-based resource map of the northeastern United States, every tick on this map equates to roughly 5 miles. The scale bar can help you determine the distance from a proposed site to the shore. The U.S. Department of Energy's National Renewable Energy Laboratory has produced offshore and land-based wind speed maps for many years. The new wind resource maps offer a snapshot of the wind resource at 100 meters above surface level. With a significant percentage of the U.S. population living along a coast adjacent to an ocean or one of the Great Lakes, there are strong economic incentives for exploring offshore wind development near coastal communities. These incentives may include revenue for communities, jobs, and lower cost of energy for consumers. Using these maps, you will find that average offshore wind speeds increase with distance from shore, and this is important for understanding the future of wind energy. 58% of U.S. offshore wind resources that could feasibly be developed exist at water depths greater than 60 meters, a point at which floating wind turbine designs take over from their fixed bottom counterparts. With this in mind, offshore wind resource maps include bathymetric lines that show water depth. In this way, the offshore wind resource maps provide a quick reference for where offshore wind development may require floating offshore wind platforms and where fixed bottom designs are suitable. When comparing land-based and offshore wind resources in the Massachusetts, Rhode Island, and Connecticut region, we can see that offshore wind resources generally provide higher average speeds over greater areas than land-based wind resources. Unencumbered by obstacles that may cause a disruption in the wind, mountains, coastal barriers, trees, and other structures, oceans offer wind-free rain to blow with minimal interference. It's unrealistic to expect every region capable of hosting offshore wind turbines will do so, but even with that caveat, U.S. offshore wind has a technical resource potential of more than double the nation's total electric generation. That's a lot of power. These maps can give you a general idea of the potential for wind energy development in your area. Now that you know how and in what context to use the resource maps, you probably want to know where to access them so you can begin to look at what wind resources are like near you. These maps can be found on the WINDExchange website by visiting Maps and Data, or you can access the maps using this link, windexchange.energy.gov/maps-data.